Good morning, everybody. I want to lead off with a quote from Great Mirror of Analysis Prince. He divides the world. Everything is about power. Everything has to have a side. Everyone knows what side they should pick. Pick it, and you're a collaborator. Reject it, a dissident. Are you or are you not on the side of power? If your actions were completely selfish, if you were an utterly egocentric sociopath, if your only goal was to get ahead and make a good impression, what would you pretend to believe? What words, what ideas would drip from your mouth? And to whose newsletter would you subscribe? This side is the side of power. To take power side is to collaborate. To stand against it is to dissent. And this doesn't tell us who's right or wrong. Real life is not a movie. If there were some cheap and accurate formula for right and wrong, how would any wrong remain? This document goes on to propose a third option. Not collaborating with power, but not dissenting against power, because what both of those sides are doing is acknowledging power, right? But the power only has power because we all acknowledge it. If we stopped, it would go away. I had a conversation last night with a homeless woman, and about 10 minutes into the conversation, I realized that this is one of the only people I've spoken to in a long time who isn't lying to me. She has nothing to gain. She was just talking about how she felt, honestly. I think one of the scariest things that we're going to have to come to grips with in the next 20 years is that you are an algorithm. It doesn't make it okay for others to treat you like that, though. I don't have a universal solution. The only thing I know for now is don't be a dissident. Don't be a collaborator. Detach. So who did their homework? Who read the paper? So, I didn't read all of it, but I read enough to, I think, begin tackling the problem. So if you recall from yesterday's stream, the problem that we're trying to solve is Busy Beaver 5. Busy Beaver 5 is saying what is the longest running or most ones printing 5-state 2-value Turing machine. Naively, there's 63 trillion of these machines. What we're first focusing on is reducing the total number of machines down to something much more approachable by using the fact that a lot of machines are so there's a few ways, there's a few classes that we can remove. So we can put machines in equivalence classes, saying that this machine is equivalent to these other 100, and therefore we only need to check one of them. If you want to check one of the other 99, just refer to this one. It's guaranteed to have the same outcome. We can also potentially remove machines that cannot possibly be the winner for Busy Beaver. I think maybe the way to think about this is domination. So what they talk about in the paper is this idea of one halting. So one halting is a machine that, well, they define K halting to be how many halting states a machine has. So if we look at go back to it's not on this page. This is just the Busy Beaver programming in general. See the non-regular page. Yeah, so these are Turing machines, and if you'll notice, they all have one halting state. In fact, this is kind of cute. They've even defined the halting state to always be B0. So there are two states that are special, and that's discussed in this paper. The two special states are the halting state and state A. And state A is special because the machine begins execution in state A. Machine states are labeled A, B, C, D, E, where A is the initial state of the machine. The halting state is labeled Z. Here they use H. So you'll notice that, when searching for Busy Beaver machines, it seems natural to focus on machines which are one halting, exhaustive, and maximizing. So the maximizing machine seems to just mean that the last step, the step to halt, it always writes a 1. If you're trying to maximize the number of ones, it makes sense to make it 1. If you're trying to maximize the runtime, it doesn't matter at all. So we can only focus on the maximizing machines and say that this number has to be 1. The paper makes a note that K halting machines, where K is greater than 1, because we're only focused on one execution of the Turing machine, we're only focused on the execution of that Turing machine on a blank tape, only one halting transition can be used. So whichever halting transition is used, the unused one can be replaced with anything, and it will clearly never get executed. So then they go on to define activity and productivity. So activity is the number of steps the machine runs. Productivity is the number of ones that it writes to the tape. Now, they talk about how, if the activity of M is infinity, meaning the machine does not halt, then the productivity of M is undefined. And I thought about that for a little bit. And at first I thought, okay, well, it probably writes an infinite number of ones to the tape, but this obviously isn't true. You could imagine a Turing machine that marches a 1 onward to infinity. And this machine is actually defined to have a productivity of 1. Well, sort of. I mean, it depends, how do you define the productivity for an infinite machine? I guess it actually cannot have a state where the 1 moves because there's no way to do an atomic swap. You can do an average of 1, but I think you could talk about limits of machines, but not really relevant to what we are discussing here. So they define a class of things that can make it irrelevant to the Busy Beaver problem. If the machine does not halt, if the machine has less activity than the total number of states, if the productivity is 0, meaning one way to know that the productivity is going to be 0, in fact, even for an infinite even for a non-halting Turing machine, I guess you can still say the productivity is 0 if it can't write ones to the tape. Imagine all of those numbers are 0. Now, figuring out whether activity is finite is, of course, the halting problem. So we're not going to have a decision procedure for that. But the halting problem, it's frequently misunderstood to say that you can never know whether a program halts or not. And this is obviously ludicrous. There's many programs that you can show they halt just by running them, and then, oh, it halts. There's also many programs that you can write trivially small proofs that they do halt. Now, what I was thinking about, and this starts to approach the limits of my mathematical knowledge, is how do you show that a machine doesn't halt? So there's one way to show it, which is to have it repeat a state. If you can show that it repeats a state, it doesn't halt. Otherwise, is it always some form of induction, right? You could imagine that the marching 1 Turing machine using induction to show that it doesn't halt. And this is about where I got to in the paper. So we're going to read the rest together. Sorry, I did what I spent time on last night instead of reading the paper. I'm very sorry, people. I made Hammer. Hammer, like Backspace, is another one of these maybe companies. Our mission is to organize the world's information and make it accessible to anyone who pays Hammer $30 a month. Our motto is, and this is all in quotes, don't be evil, and if we ever remove this motto, it's because we are evil now. And our slogan is better search, better results, Hammer. You can check it out at hammer.lol. And I think thinking about that, I have a theory that companies that have lol domains are less likely to become evil. You find not all self-serious people are evil, but I think, are all evil people self-serious? I think they might be. Yes, Papa John's, right? Don't sue me, bro. Don't sue me. Don't sue me. It's parody, man. It's parody, yo. Yeah, Hammer. It's a hammer because it's gonna smash Google, man. Yeah, but nothing can compute busy beaver numbers. Busy beaver numbers are uncomputable. At least all of them. So this is a template for many machines, as the machine will only be executed on blank inputs. All transitions are gutless goanna. I still don't totally understand their definition. Like, why are there two? Oh, I guess, so this is, in state 1, if there's a 0 present, we write a 1 and we move to the right. In state 2, right, so that will just march like that, and then I don't think it matters what you fill in there. Yeah, okay, so I think we can say for each one of these graphs, we would expect an exiting node with both a 0. For each one of these graph vertices, we would expect an edge with a 0 and a 1. So I think that is true. Yeah. Input, output, direction, new state. So this is the quintuple form of the Turing machine. The most important consequence of requiring the blank tape condition is that it will reduce the number of machines that are considered. So there's a couple ways to talk about this problem, and maybe I don't want something as strict as what they're doing. I would be okay with, say, 5x more machines to not start excluding machines that are only... This exclusion stage does not have to be aware of the problem. This is a problem-aware exclusion, which it would be nice if we could kind of break it up into two steps, a non-problem-aware exclusion and then a problem-aware exclusion. So if we can show that two machines behave completely identically, for example, with relabeling the states or switching left and right, then it's it's more universal, and we can always do the second step later. So requiring the blank tape condition is something that is specific to the busy beaver problem. Aren't there useful graph theory techniques to reduce the space of possible machines? Yeah, in a way, you can talk about this as a graph isomorphism problem. So the techniques that were historically used before this paper are techniques that run the machines while they're finding them, which I don't really like. This is something we talked about in the last stream. Okay. This stuff seems kind of interesting. For an end state M symbol quadruple machine, there's an equivalent quintuple machine. We're only interested in evaluating machines only blank input, which means to reduce the number of machines that require non-trivial analysis. So this is again doing... I said I would implement what this paper does. That's what I said I would do on today's stream, so I think we should try to do it. I mean, we can also read, they gave a nice bit of prologue code. This is the Harland paper. And they gave a nice bit of prologue code here. When I tried to run the prologue code, it didn't work. So they're using this thing called emulate search. Let's see what emulate search does. I'll make the code bigger for you guys. Very typical of academic code to just have all this stuff commented out and not use a logging system. Who knows if Prolog actually has a logging system. Okay. When generating machines for the busy beaver problem, it seems intuitively natural to concentrate on machines that are one-halting, exhaustive, and maximizing. We can ensure the machine is maximizing by specifying that any halting transition must be of this form, so they use R, but they're equivalent to the L machines. It is more difficult to say that a machine is exhaustive and one-halting. Wait, what? Isn't one-halting really easy? Oh, I guess if it's a disconnected graph, it's not one-halting. Obviously, you can have one halt transition, but that halt transition may not be connected to the A state. And that's what they're about to say, right? If you imagine a halt, you can imagine a machine that's just like jumps between the A and B states repeatedly and then has a different graph over there, and that's where the halting state is. You like the approach of lazily extending the machine. Yeah, the downside in this paper that's discussed is pretty reasonable. It says that they're grouping still two steps together here. The more we can look at this like a search problem where we're removing things at each step, it allows us to debug, evaluate, and contemplate each problem in isolation, not as a big group. It'll also reduce runtime. Consider the following partial machine. Oh man, this all is going to run into Rice's theorem, isn't it? Rice's theorem. Rice's theorem is, let's go to our own private copy of Wikipedia and look up Rice's theorem. So nice to be on your own private internet where, you know, notice how I haven't gotten a single pop-up, a single bit of spam. This is my own private internet. That's what we're going to do at the college. At the college, we're going to have a really nice private internet. Millisecond latency, right? You're talking like millisecond ping times. We'll have copies of Wikipedia. We'll have local running things like a local GitLab instance, which we can run at the scale of a college. And hopefully, I mean, it's not like you're only going to have access to this, right? We're not putting a great firewall up. But hopefully, one of our metrics of success will be if students are using the local internet more and more. As the real internet degrades in quality, our local internet can be a holdout. We can do this because obviously students can contribute to the local internet, but with strong community, there won't be crap on it. Brick and mortar university, boys. That's the way to do it. That's the way to do it. You got to do it that way. You know, there's all this online learning stuff. Do you want to go to Harvard and pay the same amount of money for a bunch of Coursera courses, but you get a Harvard degree? Oh. Yeah, no, our private intranet is going to be great. I'm not wading into the crap blogosphere. Thank you, by the way, for putting the content. The content is now on Slitstar Codex is back available. Thank you, Scott Alexander, for doing that. It turns out only crackpots are interested in cults, which I guess if I'd thought about it a little bit is not surprising. But that's why there will not be a cult. Just a university. Yeah, so Rice's theorem is what we're talking about. So let's read this text carefully. Consider the partial machine in Figure 9, which is generated as part of the process. Here's Figure 9. Here we go. Of generating 5-state 2-symbol machines. Execution of this partial machine. They're still using execution, it seems. Brings us to the configuration 1D10. 1D10, so that's, they talked about this notation earlier in the paper. So this means the Turing machine head is actually on top of this 1, and it's in state D. So what should our choices be for the transition? The set of states used in the machine so far is ABCD, and the set of symbols so far used is 0 and 1. This means we have all the symbols necessary for a 2-symbol machine, but have only used 4 states. Here we should consider only the possibilities 0, 1, LR, O. So note that it can't halt yet because if it were to halt on that transition, it would never get to state E, and then the machine would not be maximal. Man, this is using the same kind of like run the machine approach as tree normal form. All right, we could ask the question, what is the reduction factor of tree normal form on 3 and 4? And maybe the reduction factor would be similar for 5? Our next decision for the transition, okay, so it made that D transition because it was over a 1. So it made the transition to the 0 state, and now it's in, yeah. This gives us a machine in 10 in this configuration. So you could see what happened. Let's assume we chose O1 equals 1, meaning write a 1 to the tape. D1 equals R, move the head right, transition to state E. So that's what happened to get from this into this through this state transition. Our next decision for the transition is we're in state E0. Remember E, we're above a 0. Now we've used 5 states and 2 symbols in the definition so far. One possibility is to choose the transition to be the halting transition. Alternatively, we can choose from the other stuff. Yeah, it seems counterproductive to choose the halting transition as we have a number of alternatives. The problem is we have no way of guaranteeing that any of these alternatives will result in a terminating machine. To output the machine in figure 11 is one possibility and continue to search for more. So this is, I mean, it's not even partially generated, right? I think we know already what the behavior of this machine is going to be. The reason we can always ensure that the generation of an n-state m-symbol machine results in a machine which is n-state full, meaning it visits all states, and m-symbol full, it uses all symbols, is the strict monotonicity of the busy beaver function. In other words, we know that it gets bigger. This justifies the above step in which the halting transition was not considered when searching for that, meaning it's, yeah, okay. It's not saying anything too. It's intuitively obvious that the busy beaver function is monotonic in both number states and number symbols. Sure, no, I think nobody doubts that. Let's see if we can write the proof just by reading the proposition. Move this over a little. Let M be a k-halting n-state m-symbol Turing machine with finite activity. Then there is a k-halting n+1 with one more state, m-symbol Turing machine with finite activity, such that all right, let's see if we can come up with a proof for that. I'm not sure it matters, but just like a thought exercise. So we can say when the old machine was about to transition to the halt state, I think we can actually construct something that will continue to do that transition as long as there's ones. But then as soon as this one gets to a 0, it writes a 1 and it halts. All right, we'll loop back there. Do you see what I'm saying? So we can just do like, we can write like a run to a 0 and halt machine with one more state. See if that's what their proof says. Yeah, okay, so pretty much, yeah. All right, so you run to a 1. As soon as you find a 0, go to the halt state. Yeah. And it doesn't matter whether it's left or right. You can do it equivalently. Cool. Always good. It's always good to do that. Like do like a check. Like if you can predict what's coming next, you understand something, and a lot of times you don't know whether you understand something or not. Transformation is straightforward, and the method of increasing machine size is highly unlikely to be of any practical use. So this gets into like this condition is now not a condition that applies to, this is a condition that only applies to the busy beaver problem, not a condition that applies to a generic symmetry-based reduction of the Turing machine space. They've been unable to prove this result. Can we prove the result? Let's think about it. Let M be a k-halting Turing machine with n states and m symbols for some k greater than 1 with finite activity, greater than or equal to 1 with finite activity. Then there exists a k-halting m plus 1 such that the activity and the productivity are strictly greater given one more symbol. Oh yeah, that is a lot harder. It was a lot harder. See, unfortunately, we've been unable to prove this result despite it seeming to be obviously true. How much time did you put into it? One of the things that I like, and like the, I think like Donald Knuth started at, he'd rate problems with a difficulty rating from 0 to 50 based on how long it's going to take you. Whereas like 50 are open problems. 10 is something you can do in your head, 20 is something you can do in 10 minutes, 30 is something that's going to take like a day, and 40 is something that's a good research project for a semester. What is Busy Beaver 5? I don't know, 42? Finding an appropriate transformation, hence providing a proof of conjecture 28. Of course, that doesn't yet change the above thing about states. An even stronger result is desirable here, that we can guarantee that all generated machines are exhaustive. To do so would require a result similar to Prop 27, but showing the strict monotonicity of the busy beaver function in terms of the number of transitions in the machine. Okay, well, so obviously if you add another, if you add another state, you get, if you have n states, you get another m transitions, and if you add another symbol, you get n more transitions. But what if you like take away 2 states and add 3 symbols? So yeah, the monotonicity on n plus m. That's cute though. Would that be that'd be a cool thing to prove, you know what I'm saying? It should be noted that we cannot guarantee a generated machine will be one halting, as we cannot guarantee that a partially generated machine will always terminate, and so executing the machine may never result in an opportunity to add a halting transition. That's what I don't like about executing the machine. Like, I can look at the machine. I guess if I know the smaller busy beaver numbers, I know how many steps I have to execute it for before I can say that it won't terminate, right? Yeah, solving the halting problem for little machines using busy beaver numbers. Pretty cool, right? Chaitin's got some crazy arguments about this kind of stuff, about like why some busy beaver numbers are we can know them and like which ones we can't. And he kind of says that of this unknowable information, you can only get as much unknowable information out of a system as axioms you put in, which is, you know, it's kind of fun. Like lay in bed for like 30 minutes and think about that statement, and you come up with a kind of really deep philosophical truth about that. Is all math constructed on nothing? Is all relativism true? No, relativism is not true, because you can prove that Kolmogorov complexity is universal. I went through a Kolmogorov complexity book and did some proofs in it once. And I really like one of my favorite websites. You want to learn more about, you want to learn more about AI. You want to learn more truths about AI than any bullshit fast AI course where you implement the latest in transformer, blah, 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 blah. This webpage. One can prove that the better you can compress, the better you can predict. And being able to predict the environment well is key for you being able to act well. Consider the sequence of pi. If it looks random to you, you can either compress it nor predict the next digit. But if you realize that it's pi, you can compress the sequence and predict its next digit. MDL, and this is the deep truths of AI. The rest of it is just learning hip new frameworks and bullshit. Better compression requires understanding. In some cute ways, you can also talk about how science is just a quest for better compressors. We have all this data. Science comes out with these little cute formulas that tell you how to predict patterns in the data. But science also has this constraint that whatever it discovers also has to be human understandable. Math has debates about this. What is a math proof? Is a math proof something that makes the solution intuitive to humans, or is a math proof something more like you'd find in Coq, which is a rigorous proof that may be completely unreadable to any human? Me, I'm definitely in the second camp, and I think explainability of AI is the biggest scam. Oh, but how did the AI make the decision? Yeah, you ever ask a human that question? Oh, but you can ask the human and the human will give you an answer. Nah, the human's got a little part in their brain. Robin Hanson talks about this. He calls it the press secretary, that just spins total bullshit lies when humans are asked why they did something. They did some experiments in split brain people that just shows the extent to which humans will bullshit so that they can have a coherent understanding of the world. And you think you're getting a real truth about why the human made the decision. We're now in a position to define the process for generating machines. Hell yeah. This will follow the same general strategy of the TNF process. Oh, wow, this actually looks very implementable. All right, who wants to implement that? God, I haven't coded it. Coding's hard, you know? I haven't coded in a bit. I just don't feel as, like, you know, I coded like merge sort. And actually, I coded merge sort really stupidly in that stream. I don't know. It's been nice to be coding less lately. But hopefully we can write this. Let's see. I know you come here to see the lightning fast codings on the keyboard. Well, you know what? You're the wrong kind of person. This is philosophy channel. But not stupid philosophy. A lot of philosophy, like, I was on camping once. I was young, I was like 21. And I like to talk about like stupid like universe philosophy kind of stuff. Like, is the universe analog or digital? You know, like the kind of things you want to talk about when you first start smoking weed. And this guy was like, you don't know anything about that. Like, it's kind of a childish thing to talk about. And at the time, I don't think I agreed with him, but as I got older, I did. The philosophy that's much more interesting to me is the philosophy that's grounded in this kind of stuff. The philosophy that's grounded in these deep mathematical truths that requires years of studying before you can understand them. Okay. So this is the tree normal form. Let's just write it from scratch, just for enjoyability for all of you. We won't try to adapt the old code. All right, we'll call it zanyzoo.py. Sorry about the noise. Okay, let's initialize the machine with the tuple. Well, like another way to talk about that is just say 1RB in a 0. So we can say, like, let's say machine equals none times 10. Should we not do this in Python? Who wants to use Haskell? Should we use Haskell? I'm sick of Python. Sorry, everything's going to take me forever in Haskell, you know. I'm not going to be able to do things fast. I don't think we need monads. Okay. So Haskell, we're going to want to define a type of a machine. I don't know what 0 dextrous means. Should we use, maybe we'll use C++. I mean, part of the problem is going to be with writing this in Python is it's going to be slow. And like, I found myself, like, you saw even the way I started that. I started just thinking about it in terms of strings. And like, do I want to do 7 billion string manipulations in Python? Not really. All right, let's say transition. Sorry, I don't really remember C++ either. I only know Python, but I think we can muddle through with this a whole bit better. So let's actually call the states integers Let's try to use the same terminology that they use. Okay. This is the terminology. Let generate function go. Generate. Here we go. So we're going to have output, int, direction. They're technically bools, but we'll say int new state. We'll say int transition function. We're going to define n as 5. Define n as 5. The transition function is n by m. Sorry, the m isn't 5, m is 2. These aren't ints, they're struct transition. Seems right? So that's the definition of a machine. This can be private. No, we don't need this to be a class. It can just be a function. Generate. Okay. Step 1, so we want to initialize the machine to the tuple. Let's just make a macro s, which takes in a state, subtracts that from it, right? So we'll say s sub a cross 0. Oh, I have to write the stupid ass tape as well. I gotta write an infinite tape in C++. Infinite tapes are easier to write in Haskell. Okay, so this is going to be a oh, this isn't, you can't do that. Class transition sounds Marxist. Did I spell transition wrong? I think I did. No, I didn't. Okay. This isn't what I want either. I want something that's going to allow me to write this. Say 1. No magic constructor for initialization. Okay, so how do I do this? Like a colon. Yeah, it's like that, but then what do I separate them with? More colons? Or commas. We'll separate them with commas and see if it complains. Does that work? No matching constructor. Oh, we need an initialization constructor. L equals 0, D equals 0. No move. Yeah, we'll say D equals -1. You know what? Better yet. Should have I done it in Haskell? No, if I did it in yeah, I know it. I know Haskell's like much nicer at stuff like this, but like if I did it in Haskell, we would have been grappling with bullshit for a long time. Use of undeclared identifier. Oh. Calling a private constructor. All public. We like to share here. He's just not looking. Tape changes, moves, and position integers. I don't know what you're saying. Does it compile now? Okay, cool, it compiles. That's step 1. Step 2. Choose the beaver transition. Well, the first transition is obviously going to be that. I'm smacking the microphone, it's in the computer. I don't have another mic. Sorry, we got a poverty stream, boys. Poverty stream. You know what? You guys are talking about computer. That's dangerously close to keyboard. Guess what? Guess what's gonna happen? You all know what's gonna happen. That's right. That's what happens. No one's banned. Oh, you like hammers? Oh, who likes hammers? If you like hammers, check out hammer.lol. We already got 3 people who applied to come work at Hammer, but they clearly didn't realize we're only hiring for 1 role, which is founder. I'm not the founder of Hammer because I never want to start another company. If you're looking for a job, go apply to comma. That's my HN shell. We only do the Twitch stream as a funnel for hiring because we are illegitimate and we're duping you guys because we're on the side of collaboration with. I'd never do that. Subs are better people than non-subs. It's true. Glad to see all you subs enjoying it. Yeah, bye plebs. Yeah, you can waste your channel points, but let me tell you about channel points. They eventually run out. Subs are forever. Ugh. Okay. Choose the B0 transition satisfying one of the conditions below and add this transition to M. I mean, I feel like I want to enumerate these all in a loop. Like, there's not too many of them. Transition, output can be 0 or 1. Direction is left, and new state can be A. So I guess we want to try this. Direction can be either, no, direction is always left. But this can be 0 or 1. Or it can also be, since n is greater, I don't understand why this has to be a special case, but we will trust the authors of the paper. We are simply following their will. Transition can be 0 or 1, new state is C, and this can be L or R. So there's 8 choices in step 2. That code's obviously not right. You have to pick one. So we can loop through and do like a switch statement or something if we want. Okay. Execute M on the blank input until M is known to be irrelevant or a bound on the number of execution steps is exceeded. Really? This is lame crap. How do I bound the number of execution steps? I don't like this paper anymore. This is just tree normal form with like 2 extra steps added in. Thank you for all your new subscribers. We'll turn it off again. But guys, do we have to talk again today about quality? Even subs are low quality today. Don't make me sad. Hey, serious quick chat time. Why do you guys watch this channel? Especially when I do stuff like this. Like, it's fine when I'm ranting about, you know, things that anybody can have an opinion on, but one of these days I really am going to make like a quiz, right? And the quiz is going to include questions like, here's a small Turing machine. How many steps does it run for until it halts? And if you can't answer that after following through this far, we kick you out of the class. Oh, that'd be so nice. That's what we're going to do at college, man. That's what we're going to do at my new college. Every semester, if you don't know shit, you get kicked out. Doesn't help you be a better programmer. Look at my mediocre ass programming, boys. Sometimes I program well. I don't know. I'm like sick of competition programming for a bit. Maybe I'll get into it again, but when admin code comes around. All right, step 3. So we got to execute M on the blank input. So we need to write the Turing machine execution engine. We should write a class tape and implement that. I mean, so tape is really very similar to vector, except here. All right, we gotta just implement with 2 vectors. Class tape, public, what is it, like operator. Yeah, it's this. So I think we can just implement it as 2 vectors. You know what? Maybe the internet would be a better place if we all just turned on no scripts. Sorry for using STL classes. I know, I'm pathetic. All right. If L greater than or equal to 0, if forward dot size is less than L, forward dot resize L, return forward sub L, else minus L minus 1, L equals L minus 1, minus L minus 1. So that turns minus 1 into 1. Subtract 1 from that. Yeah, that gets me what I want. Let me just change this to backward here. Compile? Of course not. Non-cached L-value reference cannot bind to temporary type. Can I not use vector? Do I have to just write it? Because it's a I mean, you see why it's a temporary type, right? If I actually made it a all right, is this too ballsy for people? It might be ballsy, man. I don't know. It seems ballsy. What? Oh. Oh, are they gonna value type? Is this a const? Oh, good. No, it's not const. Oh, yes, good. Oh, that should work, though. What? No. I put it to .data. Non-const L value reference to type int cannot bind to a temporary type. Oh, maybe that. I'm doing it by reference. Alright, I just need a semicolon at the end of it. Let's test tape quickly. Alright, so we expect t sub 0 to return 0. Segmentation fault! Oh. Fine. What? But I resized it. I guess we need a value type. That's still not right. Oh, a forward size is less than L plus 1. Zero. Cool. So let's check the tape at 55. Let's set the tape at 55. Work. All right, sweet works. Oh, let's just check it at minus 55 too. High quality shit. Get it, boys. We getting zany. All right. We made a tape. Got rich off a mixtape. Should we listen to Drake just to fuck with copyright filter? Since I want speed and I try to avoid branches. I think the branch predictor will get that one fine. I mean, do you have an easy way? I guess I could call resize, but who knows what that's doing internally. I don't technically need that if statement. Well, actually, no, I do need that if statement. Because otherwise it'll resize it to shrink. Okay. Execute M on the blank input. Okay. Let's execute M. So we'll say CS equals state A, which is current state, and CP, current pointer, is 0. So we're going to say if, no, not if, we're going to get TT equals TF sub what state are we currently in, our current state, times the current, not the current pointer, but the tape sub the current pointer. And wait, that's not a TT, that's actually a transition. So maybe we can just use it directly. Who cares? This is simple type. TTF dot output. So we're going to say T sub CP equals TTF output. We're going to say CP plus equals TTF direction. I did do my directions, yeah. And if, well, actually no, we can just say CS equals TTF dot new state if CS equals -1. That should be a Turing machine runner, right? Did I do it right? Okay, well, something. Cool. And then Hotz, great. And obviously false because we didn't have any, okay, if we have an undefined input, well, gee, how can I call it undefined? I'll just say new state equals -2. Actually, we're actually going to say direction is 0 as well. So we don't actually want to add anything. Okay. So that means we got to define the state. We'll be able to set those things. Okay. Choose a new transition for M as follows. If M is n stateful and M symbolful, and the thingy is not 0 dextrous, oh god, I don't know what that means. guys. We were talking at comma about adding a restriction to the model, which says that the model's outputs must be self-consistent. And we talked about this for a bit. And it's very true that a model that makes very self-consistent, like temporally consistent outputs, all models that are good do this. But not all models that do this are good models. It's the same way about you guys talking about how I move around from insert mode into non-insert mode, you know? That doesn't make you a good programmer. Studying that stuff will never, ever make you a good programmer. Stop talking about it. Nobody gets good by studying Vim shortcuts. You get good by programming for years and years and years. Decide what you want to write, program it. You'll just get better at the tools. Nobody who's any good talks about tools. It won't make you more productive. It really won't. You watched me code this, right? It's 88 lines. Most of my time was spent thinking. Most of my time was not spent fumbling around with my editor. If most of your time is being spent fumbling around with your editor, I wish somebody told me this years and years and years ago. Yeah, tiny enough. You give me the rattiest editor on the most beat-ass computer with the worst keyboard, and I'll beat you. This stuff doesn't make you good. Okay. If M is n stateful and M symbolful, and M union a transition to the halt state is not zero dextrous. Okay, I think we're not going to get around figuring out what zero dextrous means. Add that new state to the machine. So let's write the add the halt state. Dot output equals, we always output a 1. We always transition to the right, and our new state is state underscore halt. If it's not zero dextrous, okay. I think we're gonna need to write some recursive stuff here. Because like for all of these things, we want all of them, not just one. Choice means our machine are dextrous or right-handed. Note that in step 4, they really don't define this very well. M is n stateful and m symbolful. Well, that one I can get a whole lot better. Right? So we can ask a question about the machine. This is annoying. We actually have to ask, we have to say how many states have we seen? We also need to track symbol scene. I think this is right? No, we do not actually want that to be 0. We want that to be -1. I think there's like better ways to do this in more modern C. Actually, that's not exactly what we want to do. We don't actually really want to halt there. Before we set the state, actually, I guess before we do anything, we can check to see run step. That'll actually halt, right? ttf.newState. I'm upset with the comments. Oh, I read in a page he does security contracting. I read on a page that the earth was flat, man. Yo, you should check out this page. It says global warming is a hoax promoted by the International Zionist Conspiracy. Internet's full of trash, boys. No, I just don't know what zero dextrous means, unfortunately. It doesn't seem that important, though. Check def 23 on page 15. All right. Oh, cool. Thank you. I don't know why my search didn't find that. We'll leave it as a to-do for now, because we have to address a more fundamental problem about how we choose. Like, we have choices here. I don't understand step 5 really either, but I mean, how do you actually like run this? I feel like I almost have to like copy the machine, add that one state, and then redo the procedure, right? Because look at what I mean. Look, I have the same problem up here, right? When the machine's created, you could put it online and it's going to generate links about how you can make $4,000 in 1 month using this one weird trick after you buy my ebook guide for only $28.99. And then I'm going to sit here and I'm going to rake in the dollars. That's right, because money is going to make you happier. You really think they would show you all those ads on television if the products weren't going to make you happy? Go out, get money, buy products, consume products. You will be so happy and fulfilled in your life for a bit, and then you consume more product. But don't worry, as long as you keep consuming product, America promises you a nice life. The advertisers promise you a nice life. They say it all the time in their advertisements. What do I do about this? Like, what do I do about this? This is easy in Prolog, I think. I think this is easy in Prolog because it's a logic programming language. Fucking Prolog, man. I don't really know what Prolog is, but I have an idea that you can do this kind of thing very easily in Prolog. You guys see the thing that I'm asking for, right? I mean, here, we'll write it out stupidly. For n and n equals 0 and less than n plus plus. Same thing with m. for D in, oh, this is a little annoying thing about D that I didn't really consider. Can I say something like, colon? Oh. Expected variable name or this in lambda listy. Oh, sweet. Okay. Well, it's doing something. Oh, I guess we have to set the state. ttf.output equals m. ttf.direction equals d. But everyone sees why this isn't actually right and not what we want. We want to like kind of fork every time. Great. We want to barely n cubed. I mean, those numbers are small. Love that syntax, by the way. Beautiful, beautiful syntax. Like, I wanna spawn a new. Yeah, like I want to spawn a new thread from that location every time. You know? Spawn. Yeah, after each one of those, I want to spawn. I guess that one doesn't... That one doesn't halt. Step 6 is go to step 3. Okay, what's the easiest way to write this? See, I mean, they really are threads, right? So if I wanted it to go crazy, I could actually spawn a new thread in that location. I would have to make copies. We'd have to make copies. The zero dextrous thing is not a big deal. It's just going to like reduce the space a little bit. All right, let's try to read the prologue and see how they did it. I think Prolog is a language that's like designed to be run in this way, though. I think that's kind of what Prolog is. We should have a stream where we learn Prolog. If someone buys me a mic and puts it in an Amazon locker, send a mic to an Amazon locker in the East Village in New York City, I will go pick it up, and then I'll have a mic for the streams. And you'll be a hero to the streamers who don't like hearing the mic noises. You had an exam with Prolog? You can't just set things to, maybe you can. I mean, that's, okay, so one thing we could do here is we could refactor the transition thing to allow sets. But that's not exactly right either, because would the sets be a cross or would the sets be a plus? And then this whole thing has to look kind of like a, I mean, how do I choose which one to execute? I guess I could implement a priority queue. Priority queue for the total number of steps the machine has executed. Yeah, I think that's probably right. Okay, we have to put the machines in a priority queue. Oh, crap, though. Do I have to put the tape with it? It's not just the machine. I gotta also put the tape. That means I gotta write a fucking copy constructor. Yeah. Okay. Let's class machine. And the machine has this transition function, machine M. Actually, we can make machine M, but we're also going to need to make a standard priority queue of machine. This is hard. Boys, it was supposed to be easy. ms dot push M. Okay. Let's just see if that compiles. Include QE. Forward definition of machine. that's an okay thing to complain about. I mean, okay, we can make this a function on machine. No, actually, you know what? We'll go even further with it. We'll just say, we'll call this a is full. Return state scene equals n and symbol scene equals m. So then we can just change this to m dot is full. Change that to m dot tf. Oh, we want to make a copy though. I guess before we change it, we want to make a copy. I don't know what any of that means. Variable has incomplete type machine. Is machine like a keyword or some crap? We'll call it a TM for a Turing machine. Better? Oh, good. Can't use machine, but didn't like TM either. Oh. Probably more because I put these parentheses here. This isn't Python. What language do you think you're coding in? But it also still seems to have issues with machine. T machine. Yeah, that's a good name for it. We'll call it the T machine. It's not just any machine. It's a T machine. And T machine has the same errors as machine. Okay. Machine it is. T machine only sounded good when I couldn't have machine. You know? Like hammer.lol sounded good when I couldn't have hammer.com. Oh, okay. So actually the main thing it's complaining about here is that I didn't implement the comparison constructor. Without the comparison constructor, how do we know who's better than other people? Actually, I'm just gonna make this a run function in the machine. Bool run. We don't actually need TTF. We can get that again in the run function. Don't even need this m dot because we are m. Return cs equals state halts. I'm not run. Run is a private member of machine. Everything should be public. Private. Gotta do m.t. Declare identifier t because it's m.t now because we're in machine. Okay, well that's a more understandable thing. Steps equals 0. steps plus plus, and then we'll just do comparison on steps. Less than operator C++. Comparison operator. If I had hammer, it would have already found what I was looking for. Because hammer always just knows things, you know? Hammer, it reads your mind. Return if m dot steps less than steps less than m dot steps. Invalid operands to binary expression. But I defined it now. Machines have an ordering. I put less than? I mean to put less than. Where do I have a typo? Oh, I probably need a const here. Or I need something like bool const operator. Line 56 typo. Where? I don't have Amazon. If somebody drop ships an Amazon, invalid comparison to binary expression. Const machine, const machine. Between that and that for const. I think you're right. Yeah, see? Blue spec, you're a smart guy. All right, we're making some progress, boys. Progress. See, good thing this wasn't Haskell. If we were trying to do this in Haskell, I'd have given up already. If this was Python, I would have written some egregious copy hacks and we would be done, but it would take 27 years to finish running. Okay, good. We have 8 machine. Let's just write a quick check. Yeah, okay. So I think then we want to just say, want to pop m equals ms pop. Let's actually just confirm while ms.size greater than 0, ms.pop, m equals ms.pop, and then let's just print. Let's actually make sure it made copies. What's pop? Void? Oh, top. Oh, but it's a const reference. The hell kind of crap is this? Why doesn't pop return the thing? kind of useless priority queue is this? No viable overloaded equals. I'm not happy about this. It's because I have to write a copy constructor, don't I? Cannot convert argument of incomplete type void to machine for the first argument. The implicit, all right, we knew we'd have to write this. Didn't I complain about having to write those? Copy operator. Copy assignment operator. Looks like this. It returns a machine pointer. This.cs equals m.cs. This.cp equals m.cp. This.steps equals m.steps. TF equals m.tf. Oh yeah, that's gonna go over well. Probably have to write this. And I don't know how it's gonna take this one. Tape equals m.tape. Or t equals m.t. I think we're going to have to also write a copy constructor for tape. Candidate function not viable. Cannot convert argument of incomplete type void. Oh, well, it's also complaining about that, but this argument has type const tape. But the method is not marked const. All right, we'll write the copy constructor for tape as well. Let's see if it compiles. Tape t forward equals t dot forward. Backward equals t dot backward. Copy constructor on vector. Okay, using assignment operator. This argument has type const. Oh. Oh, I don't want this const there. Yeah. Were you guys talking about that? I'm glad to see there's a hype train going on. Thank you, people. I appreciate your support. And I hate when you say dumb things. So support more and say dumb things less, and everybody wins. Control reaches the end of non-void function. Return this. Return reference this. I don't know. Return deref this. You think this? Okay, cool. Thank you. Nice to see somebody knows member reference base type int is not in a structure or union. We won't copy this for now. Who cares? Is that good? Candidate function not viable. Cannot convert argument of type incomplete void. Oh, because I'm using pop. It's not pop, it's top. Yeah, okay. Member reference base type int is not a structure or union. I don't know about that. Okay, so it's doing something, but it isn't actually working because that's not calling the copy constructor. It wouldn't return all ones if it was calling the copy constructor, right? Because I'm asking for the output, which the output is here, 0, 1, 0, 1, 0, 1, 0, 1. So it's not calling the copy constructor, it's just using the last one. Why doesn't push make a copy? Well, you know what? I can put a printf in the copy constructor. Or maybe it does, and I'm just not copying the transition table. Oh, okay. We're making a lot of copies. Damn, that's a lot of copies, boys. Where do we make these copies? Not there. Here? Not there. Oh, I mean, maybe we're not even making them here. Yeah, okay, we're not making them there. We only make them further down, and we're actually making way too many. Assignment op is not a copy constructor. Did you also write a copy constructor? Probably not. Oh, you're right. Oh, you're right. This is not a copy constructor. This is just an assignment. Oh, yeah, okay, this is stupid. Do I even need this? I meant to write a copy constructor. I don't even need this. And now it does what I want. That scares me. It now does what I want now that I removed that extra code. Better now. I'm not doing GitHub review. Okay, cool. Where do you think I made a copy constructor? I don't see one. But this seems good. Well, actually, no. There's one thing that's not complete here, and that's the tape. Yeah. Usually don't even need a copy constructor. So when I'm copying the tape, am I actually copying the underlying vectors? It's working now. That's good. Okay. So now we know what to do when we want to quote-unquote spawn. We can just say ms.pushM. All right. It should work. Why can't I call push? Oh, oops. I meant ms.com. I don't get it though. I'm calling ms.pushM there. The types haven't changed. Oh, I created a new m. That's stupid. So this is kind of crappy code. I should kind of refactor that. Okay, yeah. Use a real editor. Use something that can do this with one click. Yeah, I know them feels. All right, you all happy? Cool. All right, well, it does something. So I'm putting all the machines in a priority queue. Every time we create a new machine, we add it to the priority queue. The priority queue is sorted by the number of steps the machines have taken. We can actually add that here. They've all taken no steps. And I guess we add all of the possible transitions. Only if a state is undefined does it end up there. Wait, how does my priority queue have negative size? Ugh. Okay, it didn't add any transitions. Great. You got a lot of stupid ass languages like C++, which call it integer overflow. Oh, I remember that on a stream once. Priority queue. I remember that on a stream once where I was screaming about what a bad language it is. Like, what kind of a language has shitty numbers like that? Like, what kind of language let that happen? You know? Would you let your kids program in a language like that? Okay. If mm is full. I'm sure mm's not full. Has it not? What? Oh. Maybe we kind of want to say else mm.push. ms.push m. Okay, something. Is that really the best thing in the priority queue? Or something is aliasing. There's 47 things in the priority queue. Why is it returning one with that many steps? Oh. Unless, okay, do we really want inverted priority queue? Does priority queue give you the biggest or the smallest? Oh, largest. Cool. All right, let's first try it for this. How many machines are there here? No, we need at least that. Oh, and it shouldn't actually break if it halts. We'll say, okay, first off, why did I make mm.run return true if it halts? I'm going to make it return false if it halts and true if it should continue. And then we don't break, but only if the step actually runs do we add it back to the queue. Add back to queue if no halt, more run, please. Step 4, to do write me. Okay, it's doing something now. Look at it marching along the tape. Oh, they just keep tarring and tarring and tarring. Let's overwhelm my computer. Again. Tarring and tarring and tarring. Okay, so it seems like pretty quickly we get to 4494. And actually for every machine that halts, let's add it to a halting machines. Halting dot pushback mm. Oh, my vector has std. Okay. So it looks like this works pretty well. I mean, we're beyond the number of steps. What is busy beaver 3? Oh God, why don't I use my own Wikipedia and not be exposed to this bullshit? Yeah, my Wikipedia. Media, my wiki. So we know that we've set n to 3 and m to 2. So I would expect so 21 is there. So as soon as we get to 21 over here, you can see where we actually transition. Wow, C++ so fast. C++ is so fast. So it looks like of all the machines we enumerate, 457 of them halt, and 4494 don't halt. And we can do something else too. Let's just quickly, let's say BBN equals 0, BBN equals max, equals mm.steps. I want max. I'm gonna have to import something for max, aren't I? Oh yeah, where's max? Oh, did you mean standard max? Oh, that's declared here. Hmm, 17. Well, it's almost 21. Yeah, we got a machine that runs for 17 steps. Now let's up into 4 and see what we get. Printing on undefined state a lot. When do we print that out? Well, actually, whenever we get here, so that's not great. Oh, it's got some machines that run for 8. So it's like trying them all in like a breadth first search kind of way. This is the total number of halted machines. This is the total number of machines in general. Yeah. You don't have to print every time either. It's kind of a lot of printing. No, I don't know. It doesn't work for 3 and 2 yet, so we can fix it. Now none of these machines are going to halt. It's continuing. It's running non-halting machines, of which there are this many thousands. Okay, so things I worry about. Are we actually making a copy of the tape? We might not be. If you have a class with a vector inside of it and you make a copy of that class, is there 1 vector or 2 vectors? Oh no. To do learn C++. Or is there some reason we just didn't get the one that we're looking for? That definitely worked. Let's declared identifier. Let's change to MN. Yeah. Move semantics. No, that's not for n equals 17. Trying it for 3, 2, and we're getting the longest any machine is running in number of steps that it's taking is oh, well, okay, I mean, there's a tiny bug here where I think if we just say ms.pop, that fixes that. Because the last one we pushed is actually, I mean, actually, if we want to be more explicit about it, we can just do this. No, it's always the last one we pushed. Never mind. We run the last pushed machine right now. Oh, look, that got rid of a lot of, that made my code so much faster, boys. We got more speed. You thought as soon as I add in the 0 dextrous check, we'll have an unbelievable amount of speed. C++ so fast. Okay. Let's now, why am I only getting 17? The answer I should be getting, according to my very secure and high quality local copy of Wikipedia, is 21. You know, check over 2 by 2. Maybe that's easier to think about. 3. With some real junk here. Oh, because I didn't write it to work for... I did, actually. Oh, no, I didn't. These ones are not included. This is only if n is greater than 2. It's actually if n is greater than or equal to 3, so we'll just copy it from the paper. That's what was breaking when I said n to 2. No, sorry, that's big N, not little n. 6, okay, good. So it's working for n equals 2. It's just not working for n equals 3. But it's fast. So it can be forgiven, you know. Sometimes if you come up with the wrong answer, but you do it really, really fast, no, you're a terrible person. Don't ever be wrong. Did I write anything wrong here? Maybe I'm getting my... Okay, so I didn't do the 0 dextrous check. I don't think it matters, though. Let's just think about what we're doing. Okay, so every time we come upon an undefined state, we add a machine which replaces that undefined state with every possible state transition, both possible directions, and every possible output. Create that machine. No reason to leave since we're still going to run it. The other alternative, actually, what's probably better to write here is just continue. Right? If I just continue through the loop. No machine to run right now. Right? Alright, gives you the same answer. Actually behaves slightly differently though, which doesn't exactly make sense. But like, give me different numbers here. But I kind of feel like that's more correct, right? Because continue, going to go back up here, get me the top machine, pop it, so on and so forth. Okay. If it's full, now maybe it's full, maybe I'm not getting the definitions of these things right. Okay? What does end state full mean? End state full if the cardinality of Q equals N. Maybe step 4 matters? Or sorry, this one. If the cardinality of M, which I don't totally understand, basically, if your only choice right now would be to add, if there's only one unassigned thing, it's obviously, and there's no other halting one, add the halting one. I think that's just a speed up. I don't think that should be a requirement. Let me see if I did anything else particularly stupid. All right, there's a question of maybe we're not making a copy of the tape. We can check this. Let's just write a quick test for this. Machine M, machine M2. We know the first. I'm going to call it T. I should really call it tape. Tape is what I call the class, so too late for that. Okay, we get 1, 1, which is what we expect, and if we do that before we do it, we get 0, 0. Okay, I haven't taken any steps yet. Now, machine mm2 equals mm. We expect these tapes to be different. And tapes are different. Okay, never mind, it works. So it is copying the tape. Kraken DMP, thank you for subscribing. We appreciate every subscriber, even the ones that I don't read out on this stream. Some people get lucky. All right. It's copying the tape. There's definitely 4 there, 4 there. Let's think about what's happening if we're not hitting this undefined thing. Yeah, okay, we run, push it to the thing, otherwise it's halting, and we take it off. And we check. Yeah. Yeah, this code's not bad. It's actually pretty clean code. You think it's bad? Okay, who can find the bug? Who can find bug? I really don't think it's the 0 dextrous thing. Because that's just excluding machines. We're checking more machines than we have to. If we were checking less machines than we had to, for some reason we're not getting the machine that's the busy beaver for 3. We do get the one that's the busy beaver for 2, but we don't get it for 3. What if we do like 2, 3? What do we get? 26. Is that 26? No, again, it should be 38. So that one's not working right either. Okay, these are all simple types, except for tape, but we know that that's working okay because we tested it. With these 8 possible starting machines, we're initializing that tuple correctly. execute m on the blank input until m is known to be irrelevant, or the bound on the number of execution steps is exceeded, output m and halt. So that's what we do here. An undefined combination of the state and input is found, which is what we do here. Choose a new transition as follows. If m is n state full and m symbol full, let's be more aggressive with this. Maybe we did the definition of this wrong. There's another simpler way to define this. And we can actually just say it's just states scene. We can define it out here, and this is actually also going to be faster to run. Symbol scene sub m. And then for is full, we can just change it to this. And we say state scene sub cs equals 1. We'll set this here as well. Symbol scene sub tp equals no, it shouldn't actually be cp. This should just be symbol scene sub 0 equals 1. Scene a and 0. And here we'll say symbol scene sub ttf output equals 1. Oh, so I don't want to delete all that. I did want to leave these in there. Great. Now it gives me 1. Okay, that's already when I'm in an undefined state. Is full is about a transition. That seems correct. It seems like a lot of them are halting really fast now. There's many more are giving me is full. I guess I'm still not really understanding. I mean, maybe it's a cross product. If it's seen every state and every symbol in that state. Will that ever happen? All right. Well, I think the problem is that we're getting the definition of this wrong. So let's be more careful. M stateful. If the cardinality of Q equals N, that just means that we've defined ton of machines are halting. They've been in every state. And it just says, oh, I've been in every state. Why do I need to keep running? I've been in every state and I've seen every symbol. Now it's time to halt. But that's not right. The other halting transition in the generate process is actually much more interesting, I think. All right, let's remove that one. Let's only, well, let's do this. That should work, right? Well, no, nothing's ever going to halt. But we can add in step 4. If the cardinality of the machine, basically, if we have well, that's interesting that it doesn't even run the machine. Write one called card. If tf sub n dot new state is state undefined. If mm.card equals n times m minus 1, order operation should be fine there, then add halting to the last missing state. If mm.tf then dot new state equals state undefined, just a little redundant from above. That's probably a stupid way to write it, but we can do it, it's fine. And steps, halt. All right, still no luck. This ever happen? Am I getting crazy big numbers for that? Doesn't make any sense, does it? Can't be greater than 6. Ah. Oh. Compiler, you should tell me when I do stupid things like that. Alright, it still doesn't work. Now half the machines halt, but they all only seem to take one step. That can't be right. It doesn't even make sense. Oh, well, so this actually shouldn't really be here. Can I do this here? Doesn't matter. Okay, it definitely doesn't make sense that it's giving me 1. That makes less than no sense. How are all these machines halting, yet they've allegedly only taken 1 step? That's a scam. Okay, so those are, see, they've already taken 5 steps. How could it be returning 1? I'm on the 5s in the priority queue. It doesn't make sense. There's 2s and 3s already. Well, I guess none of them have to halt. But yeah, okay, this doesn't make sense, right? If I'm at 5 on the priority queue and I popped a machine off the priority queue there, how does it have only taken 1 step? It's not calling this constructor, right? All right, chat's getting stupid. Why is it 1? Else. Okay, the way that we end up in that else is we take a step to a machine that we just added a halting state to, but we only ever add the halting state, and this should only happen once. I don't know. Now it's also showing that half the machines halt. What's Chaitin's constant for the Turing machines? You guys should all know Chaitin's constant. But they can't be 1. It doesn't make sense. It's very upsetting. Okay, B5E1. Something in the run, could it be setting steps to 0 somehow? Who sees the bug? Who sees the bug? Oh man. Oh, God. It was an underflow in the state scene array. What a savage language. Really? What a savage language. Oh, look, it's giving me 21 now. Oh, we did it. 21 is the right answer, right? Hell yeah. 21. All right, let's check if we can get 38. So you see I'm setting 2 from 2 and 3 from 3. All right, 38, fingers crossed. No, 38. We got 26. Okay, that one doesn't work yet. Check this one. 6. That one works. Okay, cool. So increasing n seems to work. 21. Will we get 107 if we do this? Yeah, it's okay if it takes a long time. Oh, wow, it's going to take a real long time. Oh, bug life, you know? Well, we implemented that anyway, which we were supposed to implement. Now we can try the new MM is full. Maybe it will still work. Nope, it only gives us 7. So we don't really understand how to write that yet. I do want that up here. Okay. Yeah, chat's really low quality today. Oh, sorry, 3, 2. Let's see if we can make it work for this one too. I don't know. Many symbol don't really make sense to me. Oh, I know why it doesn't work. Because we have to iterate through symbols here, not states. All right, isn't that what it says in the paper? No, it says symbol choice is only 0 or 1. I mean, I guess it doesn't matter if it's the first one, right? I don't know why we only get 26 there. We do get 21 there, and that's what matters. And if we increase this to this, we get huge, big explosion. Okay. Now we can start pruning. Now that we have something that works. It's got to run this enormous number of Turing machines. Yeah, why'd no one read the paper, you know? You all had homework. If nobody does their homework, no more class. You know? Here I felt bad for only reading some of the paper. You all should feel terrible about yourselves. Read the fucking paper, you know? Like, who tried? You know what? And some of you did, and some of you did. And actually, I have a feeling, and this is again, internet tragedy of the comments. I have a feeling that there's some of you who actually tried to read the paper. And you tried, and you didn't understand everything that was said. I read it. I didn't understand everything that was said either. And you're staying quiet trying to learn. While people who are, you know, didn't try to read the paper were like, oh, I'm too stupid for that. Well, they're also too stupid to know when to shut up. Well, I didn't know there was homework. Oh, my dog ate my homework. Bro, Travis Kalanick got yelled at for saying this in Uber, but one day you're going to wake up and you're going to realize that all your successes and all your failures in life are you. They're not the other person. You know? They're not, oh, this guy, oh, if only I had this opportunity. Oh, if only I got to. Shut up, you know? Real talk. Oh, I wanted to, I couldn't, I wanted to, I couldn't. Who are you making excuses to, man? God? God's gonna judge the shit out of you. You know, every person who doesn't treat you like God is just doing you a disservice. You know, every person who buys into your excuses just lets excuses go in the world. Let's see what we can cut down on here. All right, let's understand zero dextrous. You know, it's sad. It's sad that you like the motivational speeches. Some people want those kind of tough love speeches. You know how it was in Rocky, man. The problem with self-help is if you need a self-help book to be motivated, that's not, like, it's not lasting. You're just addicted to self-help. I guess the same thing is true for anyone who thinks they need drugs to be motivated or anything like that. Like, no. And it's not easy. It doesn't just come easy. Who thinks it's some people they're able to be motivated. They just have a different brain chemistry. No, it's hard for everybody. Right? A lot of people just don't talk about it. Sir John Dukic, thank you for gifting subs. We'll switch back to non-subscriber only. You know, some people like send me things and they're like, "Oh, George, no, I've never said this to anyone before, but you're my idol," or shit like that. Like, I don't care. You know what I would care about? If you like sent me something that like taught me something and was interesting, right? I would care more if you didn't send me anything and you spent your time like learning something, learning a skill. Right? I don't care. I don't want to be famous. Fuck being famous, man. Famous people are losers, man. You know how I know they're losers? They're all drug addicts and they all kill themselves when they're 27, right? Oh, but I want to be famous, man. You know what the outcomes look like for famous people? Not great. I don't want to be famous. I want the world to know more shit. Right? Like real facts about things. It's hot in here. All right, I think where we're going to draw it today, we're going to get it to the point where we can have it do Busy Beaver 4. So right now we can do Busy Beaver 3, but I think this is actually supposed to execute early though. Like it's not supposed to run them all. Maybe what I've written now is tree normal form, but let's implement zero dextrous. So basically, I think we add it to the list only if it's zero dextrous. Some of you guys are very good. I really appreciate who caught the const bug in C++. I appreciated who brought up where the definition of zero dextrous was. Of course, I lost it. So I think we just don't want to push the machine if... yeah. Oh. I think there's another bug here too. This is actually spamming over all the states. See what I mean? Like I really have to make a copy of the machine here. Hopefully that makes a copy. Great. Now I have even more. Oh no, I'm only setting. No, it's fine. Never mind. I don't have to do that. It's not a challenger game for programming. It's a math problem. I'm trying to solve a math problem. You know, if you will allow me to indulge in a moment of self-pity, you know, why am I not doing this at a university? All right, why am I streaming this kind of shit on Twitch? I don't know. In some ways, I don't really have the, I guess I don't have the conscientiousness to like apply to a university and work in a lab where I could do this. You know, part of it is I could scream about how the university system's cocked. How, you know, they're going to ask me to write an essay about diversity and not questions about math, which I'll immediately say, wow, this institution is a bullshit institution and I don't want any part of it. Yeah, but I don't know. I'm in New York, you know? It'd be nice. Oh no, the coronavirus is going on. We can't go anywhere. Oh, that's right. Oh, yes. That's the coronavirus. I've set up a straw man there. You're right. No, that's what I said. Like, if you let me indulge in a moment of self-pity. I don't know if that's true. Maybe that's just something I construct in my head. It's probably something I constructed in my head to get out of, like it's not like I can show up, right? Because I have tried this before, and this doesn't work. I'm not sure to say that, you know, they're cocked and you're gonna have to write an essay about diversity. I don't actually know about that. But it's not like I can just like show up in a math lab, right? Like a group of people who are actually, I mean, it's a cool problem. It's not, I don't know, like a working group to kind of do this with. If I wanted to build it online, I probably could. This is not the platform for it, but again, this comes down to my lack of kind of conscientiousness, right? If I wanted to build a proper place where we could get together and work on this, you'd have to make the barrier to entry really high, not just sit down and click the Twitch stream button, largely as an excuse so I can talk to myself. Yeah, you have to be working on a PhD. I don't want to do this for 6 years. Look, I got a month in New York. I actually think if I worked with a group of people, like, you know, a bunch of, let's say 3 smart people, in the right sort of setting for a month, you know, I'd be excited about it, so it would spill over into 2. We could solve this problem, and it would be kind of fun, and it would just be like something to do. And I guess, I mean, I wish the world was more like that. Do I talk to myself casually? Yeah, but I don't verbalize. I talk to myself in my head, right? Inner monologue. You know, some people say they don't have an inner monologue. I wonder. We found the philosophical zombies. So that's actually step 5. And step 3 is defining a depth-first search procedure and not a breadth-first search procedure. Which have I thought about Recurse Center? I think I looked into them once and found my experience with it's not exactly true. I don't know. My experience with a lot of those kind of things is, I don't know about Recurse Center, but at least like hacker spaces and stuff, is it's a lot of people doing very shallow projects. And then there's people working on deeper projects, but they're kind of inaccessible for various reasons. And then there's the kind of people who show up to anything and make the whole place miserable. Some of them are taken over by those kind of people. You know, the kind of, what's that, know nothing? Let's check my private Wikipedia for a definition of that. Huh. In a weird way, it's kind of apt. But you know, you guys know what I mean. So, all right, I guess it's kind of Q&A time. We'll do a little Q&A and then we'll try to. It solves Busy Beaver 3. If we let it run, I'm sure it would solve 4, but it doesn't do it very efficiently because we got to code the 0 dextrous check. No, it's not. It's only supposed to iterate over in -1 and 1. Use sli.do to do Q&A. Huh. Let me create an account. My first name is Bob. My last name is Bobberson. My email is bobbobberson. No, my email is geohot plus bobber@gmail.com. My password is, you know, that. And my role is I work as an internal comms. Quick event. If they make you create a Slido account, my event is ready. Okay, come join my Slido event, people. Let's Slido. Oh, sweet. No one had to. Oh, yes. All right, showing Q&A. All right, well, let's see if I can create a Q&A question. If I go to Slido and I type in the number, type your question. Do you like fish? Oh, yay, it works. Oh, do you like fish? Oh, that's a good question. I'm going to upvote that. Wait, can other people upvote it? Oh, all right, I see. All right, guys, anything inappropriate ends up on here. We're Xing it out. And you know what? You know what? I'm going to minimize this. And I'm going to trust you guys to moderate. We'll just leave that there. You can find the Slido. And I'm going to trust you guys to have sanitized the responses. And if people say inappropriate things, the stream's over. Welcome to, you know, what's that? One light goes out, they all go out. No, that's not what I meant. There's a word for it. Any Turing machine is 0 dextrous if there are n transitions of the form and all n transitions are of the form 0R. I see. That just seems really easy to implement. Is zdex. You know, I kind of regret making this a 2-dimensional array. If I just made it a 1-dimensional array, I could have saved a lot of code. Okay, so first let's check if it's valid. New state. Good. Rat equals true. Not equal to state undefined. Tf sub m dot m dot. What is that? Oh. No, never mind. So that's actually, I don't even have to iterate through the m's. I just check for 0 here. Dot direction not equal to 1. Ret, if direction not equal to 1, ret equals false, break. If not, so I think we want the is z dextrous or the not is z dextrous. Not dot is zdex. Okay, that looks like less. So that gets us to 2661, 2773. Great, it saved us a whole. Oh, what a junk optimization. Okay, if M is n stateful and M symbolful. Are the questions sad? You know, the questions are sad. We're you know, maybe we'll do tomorrow's stream, and tomorrow's stream only subscribers can watch. Oh yeah, buddy, that's what I'm talking about. You know, only subscribers can watch. What do y'all think? That doesn't work. Yeah, that's right. I have to build up the subs first. No, I want everybody to get a notification, and then like, you guys can all be here for the warm-up song tomorrow, and then after the warm-up song, I'm gonna be like, subs only. Now, this one doesn't go on YouTube. This one's the one where I tell you the real secrets to learning how to program. You just gotta subscribe. See, I'm lying to you people. You know? A real sad truth about the world, man. People think, you'll hear, you know, like poor people say this thing, that kind of stuff. Like, it's the system, man. We're being oppressed by the system. And I agree with them. They're being oppressed by the system. They didn't build the system. It's unfair. What you realize about like the rich people and the quote-unquote elites is they're also being oppressed by the system. Now, you can assign them a bit more blame because, oh, well, they built the system, but they really didn't, right? Moloch built the system. They were supposed to do something about it. I agree that they had more responsibility to do something about it. But they live in the same exact terrible, systems that everybody else does, and people think they can change them, but they really can't. Oh no, I'm a revolution kind of guy. I don't think you can't change the system. Just build a better system. And my system's open and inclusive, and anyone who wants to come to the new system, then come to the new system. Oh, luck is too important in the world, man. If only I could hit home runs like Babe Ruth. If only I got luck like that. Yeah, all right. I mean, so it's an interesting thought that if we add that one back in, and may generate all correct machines, just not run them. Right? We may still be generating the machine that executes for right, so, I mean, an interesting thing to note here. No, that's not true. We're running it for 4. We expect this to give 107. Wow, these numbers are getting huge. That's the number of machines we're currently running, so we have to do that many things each step. It looks like it's kind of decreasing though. More and more machines are halting. Machine learning is this new scam, I'm going to learn, I'm going to write an MNIST classifier, and then I'm going to get hired as a machine learning engineer. No, you're not. It's a weird thing about machine learning that people think this too. I'm going to write I'm going to follow, nobody would say, I'm going to write the React demo app, and then I'm going to be hired as a React engineer. Nobody would say that. But yet people think this for machine learning. It's weird. Robin Hanson quote is, you don't want fancy machine learning, you just want linear regression and cleaned up data. I mean, it's running. It's not at least this number here represents the total number of machines in the priority queue. We could maybe make it faster. Oh, wow, we compute that cardinality every time. How bad is that? Big loopies. Yeah, we could just track that somewhere. It's making bajillions of copies over and over and over again. I guess also the machines are getting bigger. All right. Is Slido nice? Yeah, that's today's programming. Tomorrow we shall finish Zany Zoo Imp. Maybe I'll do some off stream too. We'll see. All right. Let's see what we got. Why don't I consider mods for the stream? Because you guys ask trash questions. Explain Busy Beaver 5 state to newcomers. Go back to yesterday's video and watch the beginning of it where I explain it. I'm not even, you know. No. It's good. How much time do I spend daily working on projects? 29 hours, bitches. That's right, because there's 29 upvotes there. Stupid question. Do I like fish? Wow, this was my submitted question. Actually, yes, I had fish for dinner last night. You know, I'm thinking now, like, what do I expect these questions to be? It's my fault. It's my fault for not providing any more structure in the format. But I'm not good at providing structure and format. That's not the kind of person I am. Again, like low conscientiousness. I don't want latest question. I need that to go away. There we go. Do you watch any of the streams, tabs, or spaces? I can't with you people. I can't. Who in chat knows why that's a dumb question? All right, guys. I want you to think about what the structure of oh, actually, yo, guys. You ever see the movie Limitless, man? You ever see that movie? I should have checked into my own private Wikipedia because this Wikipedia sucks. You heard of NZT48, man? Oh, see, NZT48, it's real. It's real, and the way that I stay motivated is I take it. And if tonight you come and meet me, you know, on the corner of Beverly and Wilshire, I'll hook you up with my guy. It's hot in New York, and my air conditioner is loud. Ambitious problems no one is focusing on. See, this is... I mean, it's not necessarily... Okay, so that's not necessarily a bad question. But that's a question that every single VC is asking. All right? Oh, man, we got some new kid, man. Yo, I got this guy, Bobby, out in a garage in South Dakota, man. Yo, he's working on giving wombats the ability to type. Man, yo, wombat typing, man. And like wombat typing spreads through the VC circles, right? It's not about ambitious problems. It's about boring problems. No one's focusing on boring shit. You know? But, yeah, that's the wrong... The joke about wombats and typing is wombats don't even know how to type. No. Can you reveal anything that you people know about comma.ai? Oh, you guys want to know the deep secrets. comma.ai has 2 bathrooms. One of them has a urinal, and there's something in there that kind of looks like a shower, but it's not a shower. Spell U with 3 letters. Why don't you consider mods for the stream? Won't be perfect, but it might help. So I made a few people mods. The problem is who will moderate the moderators? Right? Who will add new moderators? Moderators come and go. I'm a slacker. I don't have a schedule, right? So, oh yeah, let's put a real schedule together. Let's put effort into this, man. Have you considered a production manager? You could really take your stream to the next level. Oh my God. I don't do any of that, man. Honestly, I want a group of like a bunch of people where we can all chill and we can like read the paper and then we can work on Busy Beaver 5. Like, why am I going to stream this for you again tomorrow? Aside from a few people who caught a bunch of syntax errors in my programming, it seems like people didn't read the thing, right? I gave you all homework and nobody did it, at least from what I could tell. So why am I going to stream for you tomorrow? I'll work on the stuff myself, We tried to chill. Yeah. No, all right. Y'all got excuses. I don't care. Do I really believe that Go is stupid? No, I never said that about Go. Go is for people too dumb to program in C++, like me. You saw how many mistakes I made? I should have written it in Go. I would have made way less mistakes. They answered that. Is it better to be an introvert or an extrovert? What's this mean? What's that word mean? What are you trying to optimize for? Can't answer that. Rationality can't answer that question. I can't answer that question. How's comma.ai doing? You can read. I made a post on LinkedIn. About that. Naively, it can't be done. The reason you can't read faster is not because you can't see enough words. It's because you're in a processing loop, can't process fast enough. If you want to bootstrap that, it's going to be some crazy complex thing. That said, even though I don't get more bandwidth than using a keyboard and a mouse, moving my fingers is so much effort. Neuralink would be sick. I don't know anything about society. You know what's not a good way? Asking people what's a good way. Right? Maybe this is why, you know what? Google is the search engine you all deserve. You all deserve Google. This is the kind of, all right, to be fair, I can say that Google made people talk stupid like this, right? But I don't know. I don't know which way it went, right? Oh, let's Google this. Oh yeah, what is a good way? You know what? You deserve news articles and listicles for this. Yeah, there we go. 3 ways to internalize what you study. Quora, what's the best way of internalizing knowledge? The 9 steps that will help you learn anything. 10 definitions of learning. Google's a search engine you all deserve, man. That's why Hammer's $30 a month. It's like subscribing, but it costs more money. Oh. All right, we'll get. You gotta watch the beginning of the previous video for that. Am I optimistic or pessimistic about AGI, the singularity? Well, look, man. You wake up tomorrow and you find out you don't have free will. Do you do anything differently? That answers the question. Yeah. I don't know, man. Coffee shops. I like coffee shops. I don't like that they're not indoors anymore. I like coffee shops. Be right. See, I like this question. This is the first. This is the first good question. I mean, it's totally off topic, but it's legitimately a good question, right? The first question here is total trash. It's total trash. And this is a good question. How smart can you make a dog, right? So let's answer that. Well, all right. So first, let's go in my own private Wikipedia to neuron number animals. I have a feeling that this search isn't going to work. Oh, beautiful. Haha. Private thingy. Okay. So a dog has 2 billion neurons, and humans have about 100 billion. 100 billion. I think when you go by synapses, it's closer. But let's just say that a dog is like 40 times stupider than a human, right? Now let's ask a somewhat upsetting question, which is how many humans are dumber? What IQ makes you dumber than a gorilla, right? So if we say that maybe an IQ of 40 puts you on par with a gorilla, let's say for every halvening of the neurons, you end up with a say IQ, yeah, every halvening of the neurons gets you a halvening of IQ. I mean, IQ is normally distributed, so I'm not sure if that exactly is what I'm trying to say. Maybe we can just go by number of standard deviations, right? I mean, what I'm trying to do is I'm trying to map like the standard deviations of a human and a I don't know, maybe this is a dumb way of thinking about it. It's an interesting project. You could actually do it. And then like, yeah, what does a dog IQ test look like? I mean, it's weird to know. We shouldn't go by IQ. We shouldn't really think about it like that. We do know that from a raw cognitive perspective, humans have about 40x the horsepower of a dog. So let's just say that like everything an average human can do things 40 times faster than the average dog. Like if you're breeding the dogs, there's some normal distribution of dog intelligence, right? And some number, how many standard deviations can you get with breeding? The Gwern thing talks a lot about this, using different techniques. We should try these things in dogs, though. What's a fun project for a student to learn? Go make smart dogs like that guy. Yeah. So I think before we can really answer the question, how smart do you think I can make a dog, we're going to need some kind of like dog IQ test and to understand what the mean dog and what the standard deviation of dogs is. And then to answer that question, I would say that you could probably, through clever breeding, get dogs that are, let's say, 5 standard deviations above the mean. And that would correspond to humans with an IQ of, well, 15 times 5 is 75, so like 175 IQ humans, right? So you can get a dog that, yeah. Neurons in the neocortex is probably better, but bro, I don't know. I saw an upsetting on Hacker News. Like, this country totally bumbled the COVID crisis. If only they cared more about people's lives, right? It's like this. Please, I'm desperate. Okay. So? You got a sharp click. What did I think of NIM? It's all right. What are you doing all day in New York, going on dates? I feel like Skrelly on the live streams now, you know, sitting in a New York apartment. This looks like Skrelly's apartment. Why are the questions here so bad? I mean, for all the reasons that we talk about. Oh, the localization. I mean, this isn't. It's off topic. It's not a really bad question. I don't know. We use EKFs. Could you do better with something that understands the noise models better? I mean, Kalman filters are making Gaussian assumptions of the noise. They also assume that it's uncorrelated through time, neither of which are true, but they seem to work well. I don't know. 7 feet. I don't know what that is. Lower than Harvard. All right. That was Slido. That's what we tried today. I actually think that the subs Q&A from yesterday was better. Okay, you know what? Here's what I'm doing for tomorrow's stream. If I'm not lazy, which probably won't happen, but if it does happen, we're gonna have a test. I'll try to throw together a 10-question test to see, did you read the paper? If you read the paper, you're welcome into the stream. If you didn't read the paper, you're not welcome into the stream. And we'll have to see how we did it. We'll have to see how. But yeah, well, this is okay. We can play with these new political systems before we have to build something as expensive and intense as the university right now. Tomorrow's stream for the elite. Anyone who can pass a 10-question reading comprehension test on the paper. I'll drop the test all at once. I'll have you put in your Twitch username before you take the test. And I will trust that anyone who's smart enough to pass it won't share the answers with everybody. Or put it this way. The minute I see that answers are shared, I can cut it off there. So be somewhat fast as well. Yeah, read the paper. Read the paper, boys. Read the paper. All right. We'll see. What if no one passes the test? That would be the real sad thing, right? How many people we got? We have 864 viewers, right? What happened to the search engine? Honestly, after today, I realized that Google was the search engine you all deserved. After reading those questions today, I now no longer believe Google is evil. I now believe that the average Google user is just an idiot. You guys want listicles. You guys want to search for things as how can I be good programmer? Oh, yes. Oh, and you would love to click on 10 effective ways to be a good programmer, or 8 ways to become a better coder, or how to become a good programmer in college. Wow, that applies to me. I'm in college. Oh, how to be a great programmer. And how to become a very good programmer with a BS. How to become the best programmer in the world. A beginner's guide on how to improve your programming skills. Be a better programmer in 6 easy steps. Google is the search engine you guys deserve. I don't know. Yesterday we tried having faith in humanity. Today we tried not having faith in humanity. And tomorrow we're going to try building a wall. We're going to build a wall, and the wall is going to be made of 10 questions. Read the fucking paper. I don't know how I'll set it up. Will there be a hidden stream? I don't know. Will it be multiple choice? No, it'll be graded by my army of TAs. Make the Corona pay for it. Yeah. Should have incorporated a whole bunch of quick scam companies and gotten those PPP monies. How many people? How many? Yeah. Will it be 100% to enter? No. No. I think it'll actually be 50%. I think if you manage to get, now it won't be 50, but it won't be, I think it'll be 80. Make it 80 or something. In the right class. This is Visual Basic for beginners. Oh, I'm reading the chat on my phone. We can bring it up here. Yo, but yeah, we'll see. If I do a stream tomorrow, it's definitely not going to be for everybody. You're putting so much work into the stream. Whoa. Don't say I put in any work until I put in any work. I'm just shit talking about hypothetical work I might do tomorrow, right? If I actually do any of this, I'll be impressed with myself. I'll pat myself on the back. It's probably because I read 8 ways to be more productive with the limited time we have on Earth. The questions will be relatively easy stuff too, about like you study the busy beaver problem in general, right? Understand what a Turing machine is in general. Not a date tomorrow night. I don't have a date tonight. I don't have any plans tonight. Turing machine is a quadtuple. Yeah, what does that mean? How'd I end up talking to the homeless woman? I went for a walk, and she started talking, and I responded. It was nice. It was a rainy night. It was nice. What time is tomorrow's stream? I know. I'm gonna put an entry in my calendar. Alright. Thank you all for watching. I appreciate those who subscribe. I also appreciate those who make good comments. Everybody else, I don't appreciate you. Night, everybody.